let's just recall long division from grade school. So the reason why I'm going to go through this is because tonight's thing, polynomial long division, is a direct generalization of the long division that we learned in whatever grade you do that in, elementary school or middle school. So recall long division from grade school. Okay, so in grade school, like we learned that, like for instance, 178 divided by 3 is kind of the same as this thing. You write 3 and then you put a 178 like this. Okay, so this should definitely look familiar. I hope so. And the way you do this is you look at how many times 3 can go into 17 evenly, and that's the answer to that is 5. And then you do 3 times 5 and you get 15, and then you subtract. Okay, so hopefully this is familiar. Then you do 7 minus 5 and you get 2. Now 3 does not go into 2 at all. Thus you have to bring down the 8. Okay, and now 3 goes into 28 9 times evenly. Then you do 3 times 9, which is 27. Subtract, and you get 1. And this 1 here is the remainder. Okay, and the way this works is just, so pretty much the conclusion is that, so 3 goes into 178 3 times with a remainder of 1. Okay, so that's the conclusion of this little algorithm that we did. All right, and let me just write this. Alternatively, this can be written as so alternatively, through this process here, we have rewritten 178 as such, as 3 times 59 plus the remainder of 1. Okay, so 3 goes into 178. Oh no, not 3 times. Wow, okay, I wrote this incorrectly. Up here, I wrote 3 goes into 178 3 times. Now it goes into it 59 times, excuse me. Okay, so if you catch me making a mistake, please just shout it out, all right? Okay, so alternatively, we can write that 178 is equal to 3 times 59 plus 1, and we can divide both sides of this by 3. Divide both sides by 3, and you will get this. So divide both sides of this equation by 3. Get 178 over 3 is equal to 59 plus 1/3. Okay. So we just want to realize this division as these, and as rewriting it as these, as in both of these ways, okay? We want to look at it as writing it as 3 times 59 plus 1, but also 178 over 3 is the same as 59 plus 1 over 3. All right, so we just want to be mindful of that when we jump to polynomials. All right, so any questions on long division of numbers? Just this review. All right. So we're gonna just jump now into polynomial long division, a direct generalization of this process of long division of numbers. We're not going to do this with polynomials. All right, so let's see how that looks. So the heading will just be polynomial long division. Okay, so as I said, we now extend this procedure to polynomials, and this is how it looks. So suppose we want to compute 6x squared minus 2x minus 28 divided by, so when I write the fraction bar, it really means dividing by 2x plus 4. Okay, so we want to figure out how can we divide 6x squared minus 2x minus 28 by the polynomial 2x plus 4. All right, so I'm going to explain the technique through this concrete example. All right, I think it's best explained through a concrete example. So the first thing you do is you just set it up the same way you do it with numbers. So you put this 2x plus 4 that's in the denominator, you put that out front, and then you kind of write this symbol. I don't know the technical term for this symbol here. So and then you put the numerator inside of this thing. 6x squared minus 2x minus 28. All right, so far it's exactly like dividing numbers. Okay, so this is how you do it. This is how you do it. So you ask yourself, you look at the leading term, 2x. You ask yourself, how many times does 2x go into 6x squared? Or in other words, 2x times what is equal to 6x squared? Well, 2x times 3x is equal to 6x squared. I hope you would agree. So that's the number, that's the polynomial that you put up here. Okay, so you ask yourself again, 2x times what is 6x squared? And the answer to that is, well, 3x. 2x times 3x gives you 6x squared. Okay, next, you multiply this number out here by 3x. So 2x times 3x is 6x squared. And then you do 4 times 3x. And 4 times 3x is 12x, and you put that 12x right here. Now, you subtract. And very importantly, you definitely should put parentheses around this polynomial that you'll be subtracting. I urge that strongly, because if you don't, there's just going to be some problem with this minus sign out here. So just put a parenthesis, so put a set of parentheses around this. And now you just subtract. So 6x squared minus 6x squared, that's 0. And that's always going to be 0 there. And now, pay attention, this is negative 2x minus 12x. Negative 2x, that minus sign, 12x. And that is just going to be negative 14x. Okay? Okay, very good. And now we can bring down this minus 28. Okay, next we do the same thing now with 14x. So 2x times what is negative 14x? 2x multiplied by what will result with minus 14x? And the answer to that is negative 7. Because if I do 2x times negative 7, I will definitely get negative 14x back. Okay, so now you multiply each guy here by negative 7. So 2x times negative 7 is negative 14x. Okay, negative 14x. And 4 times negative 7, so you also do this 4 times negative 7, that's negative 28. Good. Now put parentheses around this and subtract. All right, very important to put these parentheses here. Okay, so we have negative 14 minus negative 14, which is the same as negative 14 plus 14 because of the double negative, that's 0. And you also have negative 28 minus negative 28, which is negative 8 plus 28, so that's 0. Okay, so the remainder is 0, and we're finished. The reason why we're finished is because there's nothing else to bring down. Okay, so that's how you know you're done. Okay, so this is the conclusion. The quotient, aka your answer, is this top row that you came up with. So the quotient is 3x minus 7, and the remainder is 0. Okay, so that would be it. Yeah.
I have so many questions. Okay, one, how I got really confused. How do you get from the minus 2x to the plus 12x?
Oh, to get this plus 12x, I did. Where did I get that from?
The 4 times 3x, right?
Yes, exactly. Right. So thank you. Yeah, so exactly. So when this row right here, this 6x squared plus 12x, that was obtained by doing 2x times 3x and then doing 4 times 3x. And 4 times 3x is plus 12x. So that's that.
Okay, thank you.
Okay.
That explains another thing as well, so thank you.
Okay, good. Do you have any other questions? We're going to do more practice. So
Yeah, not right now, maybe later.
okay. Okay, so we're going to go through this procedure like I think two more times. So we're going to get more practice with this. Okay, but the final answer of a question like this would just be to just write the quotient is 3x minus 7, which is this polynomial up top, and you write the remainder. Okay, so let's just kind of compile everything that we have done here. So thus, the thing that we started with, remember, it was 6x squared minus 2x minus 28, and we divided that by 2x plus 4. This was equal to 3x minus 7 plus 0, plus the remainder.
Professor Roberts,
Yes.
do you think it would be a little bit more conducive and speedy to do it? If we just did 6x squared divided by 2x, that would be 3x. If we did negative 2x divided by 2x down there, that would just be canceling each other out. And then negative 28 divided by 4, that would just be negative 7.
Okay, so you cannot split fractions up like that.
No?
The only way you can split up a fraction similarly to what you just said, you would need to do 6x squared over the whole entire denominator.
Got it.
Minus 2x over the whole entire denominator. Yeah, you can't just pick terms of the denominator to split it up like that.
Fair enough. Thank you.
Yeah, that would be, I wish you could, but unfortunately, no. All right, so what we gathered, so remember what the question was. Let's not lose sight of the question. We just did 6x squared minus 2x divided by 2x plus 4, which is this. And we have figured out that it's equal to 3x minus 7 plus 0. Okay, now, just like earlier when I did it with the numbers, I can multiply both sides of this equation. So I can multiply both sides of this equation by the denominator, 2x plus 4. And that's going to let us see this in a different way. So if I multiply both sides by 2x plus 4, the 2x plus 4 here cancels. Okay, so that will go away, and I'm just left with the numerator, 6x squared minus 2x minus 28, and that will be equal to 3x minus 7 times 2x plus 4. So I hope that's just algebra. I just multiplied both sides by 2x plus 4. Sorry, my dogs are going crazy right now. So what's interesting, if you know, like, look what happened. We actually were able to factor this quadratic using polynomial long division. We actually factored it as 3x minus 7 times 2x plus 4. So that's a hint of things to come. All right, so just put that in the back of your head. We did factor this. And the reason why we're able to factor it is because the remainder was 0. Okay. So let's keep moving. We're gonna do another example. Okay, so the task will be to compute, same as before, just a different polynomial, compute 2x cubed minus 3x squared plus 4x plus 5 divided by x plus 2. Okay. So the denominator, x plus 2, gets put out front like that. And then you open up this bar thingy. I don't know the name of this symbol. And then you put the numerator inside. So this is 2x cubed minus 3x squared plus 4x plus 5. Okay, so always the denominator will go out front and the numerator will go inside of this little box. All right. All right, so now we do the procedure. So we look at x and we look at 2x cubed. X multiplied by what will give me 2x cubed? Well, I think 2x to the second power does the job. Okay, x multiplied by 2x squared will give me 2x cubed. Now, you multiply each of these guys by 2x squared. You multiply x by 2x squared. That will give me 2x cubed. Now I do 2, this plus 2 multiplied by 2x squared. And that will give me 4x squared. Okay, and now you subtract. So you put a minus sign and you put parentheses around this. I really would like to see everyone put parentheses around this because it can lead to errors. All right? And now you just subtract. So 2x cubed minus 2x cubed is 0. That's really always going to happen by our setup. And now you do negative 3x squared minus 4x squared. So negative 3 minus 4 is what? Negative 7? Negative 7x squared. All right, so this was, so I got this negative 7x squared by doing negative 3 minus 4. All right, good. And now you just bring down this plus 4x. And now we actually just continue. We do the same steps that we did right here. We just continue the algorithm now. So now you ask yourselves, x multiplied by what will give me negative 7x squared? X multiplied by what polynomial will give me this negative 7x squared? Well, I think negative 7x does the job there. So you put that up top. Negative 7x. And now you multiply each of these terms, this x plus 2, by minus 7x. Okay, so x multiplied by negative 7x will give me that negative 7x squared. And 2 multiplied by negative 7x will give me minus 14x. All right, so then you subtract, put a minus sign, and put that in parentheses, please. All right, are we all okay so far? Okay, so now do the subtraction. So negative 7 minus negative 7, that's going to be 0. And now you do 4x minus negative 14x. You have a double negative there, so that's just 4x plus 14x, which is just 18x. So 18x. And bring down this plus 5. Okay, almost done. Very close to being done. Okay, now we just repeat. So this x multiplied, so x multiplied by what will give me 18x? X multiplied by what will give me 18x? Well, 18 itself works, so I will just put a plus 18 up here. Okay, so x multiplied by 18 will give me that 18x, so that's good. And now you just multiply each term of x plus 2 by 18. So x times 18 is 18x, and 2 times 18 is 36. 36. Okay, and now you subtract. So please open up, please put a minus sign and put that in parentheses. And we are done. So 18x minus 18x, that's going to be 0. And 5 minus 36 is negative 31. Okay, and we are done because there's nothing else to bring down. We're done. So negative 31, that's the remainder. Okay, so the final answer to a question like this should be stated as such. So this is how you write your final answer. You write the quotient is, and you just go up top here. The quotient will just be what's ever on top of the little box. So the quotient is what's on top there. So it's 2x squared minus 7x plus 18. Okay, so I hope everyone sees where I got this from. It's just the polynomial that's sitting on top of this box. And the second thing you write is the remainder. The remainder is negative 31. Okay, so that's how you write your final answer. Yep.
Another question. Does the subtraction always starts with a 0? Like, I'll explain. Like, the 2x cubed minus 2x cubed always will be 0, the subtraction, or is there a possibility I'll have something left, so I'll need to keep on for the next part?
Yeah, so if you did this right, you will always get zeros at that step. You'll always get 0 here, here, here.
Okay.
And think about why, and you can think about why that's true. We asked ourselves, x multiplied by what is 2x cubed? The answer to that is 2x squared. And remember how you get this line right here is you literally multiply x by the thing you said would give you 2x cubed. So it should give you 0.
Yeah, so it's always possible. Yeah, of course. Okay, yeah, sorry. That was not smart of me.
No, that's definitely a great question. So we're actually forcing it to be 0. We're forcing a 0 here by by this 2x squared. So yeah, so very good question. So this is how you would write the final answer. Just clearly write your quotient and clearly write the remainder. All right, I would appreciate that. And we can also write it in this format too. So thus, 2x cubed. So I just want everyone to be familiar with all the different forms we could write this as. 2x cubed minus 3x squared plus 4x plus 5 divided by x plus 2. This is equal to our quotient, 2x squared minus 7x plus 18, plus the remainder, minus 31 over x plus 2. Okay? So you put the remainder over this expression that's in the denominator, okay? So that's one form. And now I would just like to show you guys you can multiply both sides by x plus 2 to clear the fractions. So you're just left with 2x cubed minus 3x squared plus 4x plus 5 is equal to x plus 2 multiplied by 2x squared minus 7x plus 8 minus 31. So I hope everyone sees how I obtained this line here. Just multiplied both sides by x plus 2. So here's another thing to think about look at what prevented us from factorizing this polynomial, 2x cubed minus 3x squared plus 4x plus 5. What prevented us from getting a pure factorization? It was this remainder. If that remainder was not there, we would have factorized this third degree polynomial. Okay, so this is something to come. If the remainder is 0, we can actually obtain a nice factorization via polynomial long division.
Just real quick, in the second set of parentheses, did you mean plus 18 or is it plus 8?
Yes, thank you. Definitely plus 18. Thank you, Luke. 18 there and 18 there. Good. Okay, so just let me just say that again. It was this remainder of negative 31 that has prevented us from getting a pure factorization of this left hand, of this 2x cubed minus 3x squared plus 4x plus 5. All right, so special things will happen when the remainder is 0, like in the previous example.
I have a question.
Yes.
It's the 2x squared minus 7x plus 18 minus 31 over x plus 2. Why is the x plus 2 there? I missed that.
Right. So, you actually, I probably should have done this in the other order. You actually get this from the bottom here. So imagine if you were to multiply both sides of this equation, divide both sides of this equation by x plus 2. You would get this 31 over x plus 2. So you get this guy from the division. That's just like the definition of doing a division. You have this quotient multiplied by x plus 2 minus the remainder. It was like when we did 178 is equal to 3 times 59 plus 1. So the analog of this was down here.
Okay, I understand. Thank you.
Right. And then you divide both sides by x plus 2, and that's why you get a 31 over x plus 2. So that's a nice point. I should have probably started from this guy. So hopefully that's good. Okay, so good. So let's just move on now if no one has any more questions. So there's just a special case we need to cover. So we do the case when some powers of x are missing. Okay, and let me just explain what that means. So consider the example 3x to the 4th minus 12x plus 5 divided by x plus 1. Okay, so let me just point out to you that the numerator, aka this guy, 3x to the 4th minus 12x plus 5, has no x cubed or x squared terms. All right, I hope that should be very clear. And there's no x cubes and there's no x squared terms, okay? So in this case, you need to rewrite it as such. And it's a very simple rewrite. In this case, it is necessary to rewrite that numerator. So all you do is you just put zeros in for x cubed and x squared as such. 3x to the 4th plus 0x cubed plus 0x squared minus 12x plus 5. All right, and just convince yourself we actually did not change the polynomial at all. Okay, we just introduced the x cubed and x squared via writing it with a coefficient of 0. All right, so we didn't change anything. And it's just necessary to do this to perform the polynomial long division. All right. All right, so now set up the long division. All right. So that's all you have to do when there's powers of x missing. Okay. So now it's the same as before. You have a question?
Yeah, do you always need x cubed or x squared in each time you divide?
Yeah, so if your highest power is, say, 5, you need to account for anything lower
Got it.
that's missing. So our highest power here is 4. So we ought to have every single power down from 4 present.
Okay, got it.
Yes. Mm-hmm. Okay, so now it's the same as before. So you put this x plus 1 out front. And now we put this rewritten version of the numerator inside of the box. All right. So you put here 3x to the 4th minus 0x cubed plus 0x squared minus 12x plus 5. All right. So that's the only difference. And now you just complete the algorithm just like before. All right. So let's go through it. All right, so let's maybe do this slightly quicker. So x multiplied by what will give me a 3x to the 4th? Well, I think 3x to the 3rd works. So that's what you put up here. And now you multiply x plus x and plus 1 by this 3x to the 3rd. So x multiplied by 3x to the 3rd will give me precisely 3x to the 4th, and 1 times 3x to the 3rd is just 3x to the 3rd. All right, so far so good. Now subtract, and please put this in parentheses. Put a minus sign and then put this thing in parentheses. It will make, it just will make your life easier. All right, and now we just subtract. So 3x to the 4th minus 3x to the 4th, that's 0. Okay, you don't need to write this 0, by the way. I'm just doing it just to be clear. And then we have 0x to the 3rd minus 3x to the 3rd, and that's negative 3x to the 3rd. Okay, and the next thing to do is to bring down this guy. So I'll bring down a plus 0x squared. And now you repeat. Perform the steps again. So x multiplied by what will give me negative 3x cubed? Well, that would just be minus 3x squared. Okay, so that's what you put up here. And you multiply each term of x plus 1 by negative 3x squared. So x multiplied by 3x squared is negative 3x cubed, and 1 multiplied by negative 3x squared is negative 3x squared. Okay, so put a minus sign and put that in parentheses. Okay, so negative 3x cubed plus 3x cubed, that is 0. And we have 0x squared minus negative 3x squared. You have a double negative there, so it's the same as 0x squared plus 3x squared. And that's positive 3x squared. All right, and now bring down this minus 12x. And repeat. So x multiplied by what is 3x squared? That's just 3x. Okay, x multiplied by 3x will give me 3x squared. And now just multiply each term of x plus 1 by this 3x. So x multiplied by 3x is 3x squared, and 1 multiplied by 3x is just 3x. Okay, good. Subtract, put that inside parentheses. Okay, 0, 3x squared minus 3x squared is 0. And now I have negative 12 minus 3x, which is negative 15x. Okay, and we just have one more to do. We just have to bring down this plus 5. Okay, last one. X multiplied by what is negative 15x? That will be just negative 15. Okay, x multiplied by negative 15 will give me negative 15x. And now just multiply each term of x plus 1 by that. So x multiplied by negative 15 is negative 15x, and 1 multiplied by negative 15 is negative 15. Okay, subtract, put that in parentheses. So you get 0, and you have 5 minus negative 15. You have a double negative, so it's 5 plus 15, which is 20. We have nothing else to bring down from up here, so we're finished. Okay, here's your answer. Quotient. So this is how I would like you guys to format your final answer. The quotient is, if you just go up top to whatever you have obtained on top of the box. So the quotient is 3x cubed minus 3x squared plus 3x minus 15. And also just tell me what the remainder is. The remainder is 20. Okay, so you can stop here. This is definitely a legitimate final answer. But I also just like to emphasize like what we have achieved in the process. We have rewritten our fraction as such. Okay, so remember the thing we did 3x to the 4th minus 12x plus 5 divided by x plus 1. We have now kind of decomposed this as such. You write it as the quotient, 3x cubed minus 3x squared plus 3x minus 15, and then you add the remainder, but you put it over x plus 1. Okay, whatever you were dividing by, plus 20 over x plus 1. Okay, so I just like to write this. This is like another way of seeing what we have done. We have like decomposed this fraction into a quotient plus a remainder.
Just to reiterate, just to confirm, you put it over x plus 1. Why is that? I mean,
yeah. So by the definition of division, we have rewritten 3x to the 4th minus 12x plus 5. We have rewritten this as x plus 1 multiplied by this guy, 3x cubed minus 3x squared plus 3x minus 15, and then plus 20.
mm-hmm.
So this is just by the definition of division, and you can see that by our example from the beginning of class when we did 178 divided by 3. You rewrite 178 as 3 times 59 plus 1.
Okay.
It's the same thing, but you do it with polynomials.
Got it.
So this is from the division, and you obtain this by dividing both sides of this equation by x plus 1.
Okay.
So you see how the x plus 1 here would cancel, but you introduce a 20 over x plus 1.
Got it.
That's how you get it.
But it would still be the same answer, though.
Yes, these are equivalent equations. These are exactly the same.
Got it.
But you can really just leave your answer like this. Just quotient is, remainder is, and call it a day. I'm totally cool with that. I just want to just highlight what we have done. We have decomposed our fraction into a sum, which is kind of interesting, and this will be useful in Calculus 2 if anyone decides to take Calc 2 when you do partial fractions. So that's something later down the line. Okay, but polynomial long division is used later in math, like in Calc 2. Okay, so I think, all right, good. So that will do it for the polynomial long division, all right? The best thing to do to get good at this procedure is just the practice. Just do practice problems, and the homework will have practice problems for you guys, all right? So just work on those, and you'll just really solidify the technique. Because it is a little overwhelming. I remember when I learned this back in the day, it was confusing. But the way to get good at it is just practice. Get it into your muscle memory. Okay. Okay, so I will move on to the next thing if no one has any questions. All right, so you guys are going to probably enjoy this. This is way easier and faster than the polynomial long division. So we have something called synthetic division. Okay, synthetic division. All right, let me just quickly explain what it is, kind of. So, or its use. We have a fast and simple procedure for dividing things of this form. So it's only applicable for a special form, P of x over x plus k, where P of x is a polynomial of degree 2 or higher, and k is just some number, just some real number. So if we are given a division problem where it's of the form P of x over x plus k, we do not need to do polynomial long division, which is what we just did earlier. We have a very fast and I think somewhat fun procedure that's much quicker than polynomial long division. All right, so let's just go straight to an example. Again, I'm going to instruct the technique with a concrete example. So, example, we can use synthetic division to compute this, division. 5x squared minus 3x minus 36 divided by x minus 3. So I just want to make note is that this setup follows the correct format for when synthetic division is applicable. We have in the numerator a polynomial of degree 2 or higher, and in the bottom here we have x plus a number. In this case, it's x plus negative 3. Okay. You have a question, Luke?
Yeah. Does it can it only be one exponent? Like if you were to have the previous example, 2x to the third minus 3x squared, etc., would this work out or no?
Yes, the previous example, because the denominator is x plus a number, yes, synthetic division is applicable on this example.
Great, thank you.
However, you would need to replace zeros.
Got it.
replace it with zeros. And we're going to do that. Don't worry. Yeah, we're going to get to that.
Thank you.
All right, so here's how it works. This is so much better and way faster than synthetic division, but than polynomial long division, but it's not applicable in general. It's only applicable in the special case where you have a polynomial of degree 2 or higher divided by x plus a number. Okay, so what is k in this example? Here, k is x plus negative 3. Let me think. Oh, shoot. Okay, wow. I actually made a mistake. I should have written x minus k up here. So excuse me for that. So if you wrote that down in your notes, just go and fix that. Change the x plus k to x minus k. I'm sorry. All right, so my bad. So in this example, k is 3. We have x minus a number, and that number here is 3. So let's just make note of that. And what you do is you take the coefficients of the numerator. So take the coefficients. Take the coefficients of the numerator. Okay, and you write it in like in a little array like this. You do so the coefficients first of all are 5, -3, and -36. So just write in a line here 5, -3, -36. Now kind of write this half box and put your k value right here. So k is 3, so put your k value right there. Okay, so this is just the setup, and here is the procedure. Okay, so take this number 5, bring it down, put it here. Good. Now do 5 times 3 and put the result of 5 times 3 right here. 5 times 3 is 15, so I will put a 15 right here. Now you do -3 plus 15. You do this number plus whatever number is there. So -3 plus 15 is 12. That's why I'm putting a 12 there. Okay, now do 12 multiplied by your k value, 3. 12 times 3, and put that here. So 12 times 3 is 36, so you put the 36 right there. And again, add this column. So -36 plus 36, and that's 0. Okay, and we're done. We actually have divided the polynomial already. So way faster than polynomial long division. But how do we read our final answer from this? Like what do these numbers mean? Okay, so first of all, the final number in the bottom row, the final number in the bottom row is the remainder. Okay, so the final number in the bottom row here is 0. In this case, it is 0. Okay, and how about these other numbers that are in this row? Okay, well that's actually your quotient. Those are the coefficients of your quotient. So the other numbers in the row are coefficients of the quotient. Okay, so you need to just So what is 5 the coefficient of? Is it the coefficient of x squared? Okay, well, just look, our numerator was 5x squared minus 3x minus 36. Your quotient will be 1 degree lower. It will be a polynomial of degree 1 in this case. So the 5 is actually a coefficient of x. Okay, so in this case, it is 5x, that's your highest degree. So it goes 1 degree lower than the numerator, plus 12. 5x plus 12. Okay, so that's the plus 12. All right, so we are finished. So a much faster way to do the polynomial long division. And just another way to write this, let me just do what I've been doing before. So what we have done here is we have rewritten 5x squared minus 3x minus 36 over x minus 3. This is equal to the quotient 5x12 plus the remainder. Well, the remainder is 0. So I don't even write that. I don't really need to write that. And if I multiply both sides by x minus 3, well, look, something special happens. I have 5x squared minus 30x minus 3x minus 36 is equal to x minus 3 times 5x plus 12. So since there was a remainder of 0, we were able to factor the polynomial 5x squared minus 3x minus 36. So that's something that we're going to look at later and the next lecture. Okay, when the remainder is 0, you get a factorization of this numerator. All right. All right, so we're gonna do more examples with this synthetic division. All right. So any questions about anything? Okay, we're actually going to do an example from earlier. So this is it's not, I forget how many examples ago it was, but this is an example from earlier. But now with the technique of synthetic division. Okay, so I just kind of want to show you that you're going to get the same answer if you use synthetic division. So the example was, it was 2x cubed minus 3x squared plus 4x plus 5 divided by x plus 2.
Going to be x plus 2, or is it going to be x minus 2?
So the question is this: we're dividing by x plus 2, but our k value will be negative 2.
Can we do that for like any case? We could just make it negative 2?
Yeah, because remember we look at p of x over x minus k, right?
Right.
So here I'm rewriting x plus 2 as, I'm thinking of it as x minus negative 2.
Oh, okay.
So negative 2 is playing the role of k. You see how this looks just like that now?
So you can manipulate it no matter what.
Exactly. So it does not need to be x minus a positive number. It can also look like this, x plus 2. In that case, your k is just going to be the negation.
Got it. Thank you.
Yeah. So very good point. Yep. Okay, so I just want to make note that this is a situation where synthetic division is applicable. Okay, in the numerator, we have a polynomial of degree 2 or higher. It's, in this case, it's of degree 3. And we're dividing by something of the form x minus k. So just in your head, be like, oh, good, synthetic division is allowed. Okay. All right, good. So we just set it up like before. You take the coefficients of your numerator and put them in a row. Okay, so I do 2, -3, 4, and 5. All right, so just read off those coefficients. Now put this kind of box thingy and put your k value over here. So k is -2, so I'm going to write that here. Okay, and now here's the setup, and now we can start the set of steps. So first thing to be done is you bring this number down. Bring it down. It's 2, put an arrow, and then put 2 in this bottom row. Now do 2 times -2. That's -4, and you put that right here. Very good. Now do -3 plus -4. So you add this column together. -3 plus -4, that's -7. Because -3 plus -4 is the same as -3 minus 4, which is -7. Good. Now take this number, -7, and multiply it by your k value, -2. That will give me a positive 14. -7 times -2 is positive 14, so I'll place it right here. And again, add this column together. Do 4 plus 14. 4 plus 14 is 18. All right, so far so good. Okay, now do this number 18, multiply it by the k value, -2. So 18 times -2 is -36. So put that right there. And add this column together. So 5 plus -36, that's the same as 5 minus 36, and that is -31. And we're done. So this is so much faster and easier than polynomial long division. All right, so we are done. So first of all, the remainder is just that last number in the row. So the remainder is this final number. So it's -31. Okay, and the quotient is, so the other numbers that are in the row are the coefficients of your quotient. Okay, so we have to go back to the original problem. We had in the original problem, the numerator was a polynomial of degree 3. That means our quotient will be a polynomial of degree 2. So this 2 is the coefficient of x squared. So the quotient will be 2x squared minus 7x plus 18. Okay, and another way to kind of get at this quotient is to look to the left of the remainder. This will be the constant term, so the plus 18. This will be the coefficient of x, and this will be the coefficient of x squared. You can also look at it that way. You can kind of just travel backwards and see what power you end up with. All right. All right, so you will notice that we got the same answer from when we did this example earlier in class. So I'll do another example if no one has any questions. All right, next example. Okay, so the example is this. -9, sorry, wrote that sloppy. Okay, so the example is -9 x to the 4th plus 10x to the 3rd plus 7x squared minus 6 divided by x minus 1. Okay, so we're in the case now when we're missing some exponents of x. Okay, you'll notice that the numerator is missing an x term. Okay, so here the numerator has no x term. It has no linear term. Okay, so just like earlier in the polynomial long division, you have to put a 0 in its place. You must. So we use a 0 as the coefficient for that term, okay? So we use a 0 as the coefficient for that term. All right, so just like earlier, when we were missing some powers of x, we had to write it as 0 as the coefficient. All right, so here we go. So we just set up this thing again. We have to read off our coefficients. So we have -9, 10, 7, 0, and -6. So hope everyone sees what's going on. Look, I went from 7 to -6, but I put a 0 in between them to account for no x term. All right, so here is that 0 that was mentioned above. All right, so very important. You're not going to get the right answer if you don't put this 0 here. All right, so you have to do it. Good, so now we set it up. So write this, so just kind of draw in this box thing and put your k value. So k is going to be is going to be 1. K is 1 here, so I just put a 1. That's the setup. And now let's just go through the algorithm. So take this -9, bring it down. That'll be a -9. Now you do -9 times 1. That's -9. You place that right here. Now add up this column. 10 plus -9. That's 1. So it's the same as 10 minus 9. Now you do 1 times 1, which is 1. Put that there. Excuse me. Now add up this column. So I have 7 plus 1, which is 8. Now you do 8 times 1, which is 8 again. So I hope everyone is kind of seeing the general model that I'm following here. Now add up this column. I have 0 plus 8. So I get an 8 here. Okay, and now do 8 times 1, which is 8. So I put that here. And now you add up the final column. So you do -6 plus 8, which is 2. And you're done. You're done. So 2 is the remainder. That's the remainder. And the quotient is, so remember the other numbers in the bottom row, those are the coefficients of our quotient. So there's 2 ways to think about this. In the numerator of our original question, it was a polynomial of degree 4. That means our quotient will be a polynomial of degree 3. So this -9 will be in front of an x cubed. That's one way to think about it. The other way to think about it is to kind of work backwards. So 8 will be the constant term, 8 will be the coefficient of x, 1 will be the coefficient of x squared, and -9 will be the coefficient of x cubed. So 2 ways to think about it. So that's it. So just take your bottom row and place them as coefficients. So -9x cubed plus 1x squared plus 8x plus 8. Yes. All right.
Kind of a question, not really. I don't know.
Uh-huh.
Can, like, if k can be any number, can I say k is x and like break it? I don't
Uh,
know.
K is x. Well, we already have an x here. So if k is x, you would have x minus x.
Yeah, no, but like not like x, but like x squared or like oh, because then I would go to like a quadratic equation,
Right. You
right?
need a linear. Right. Good. Good. You need a linear term in the box.
Yeah.
Yeah, you have to divide by something that's linear, and in particular of the form x minus a number.
Okay.
But
Yeah.
that number, though, the k, that can be a fraction, or it doesn't need to be a whole number.
Okay.
It could be like x minus a half or something. That would work.
Then you do like the same process, but instead of like dividing, you're like multiply. Or am I going
Right.
crazy?
So instead of a 1 here, I would have like a 1/2.
Yeah.
And you do the same set of steps. Yeah.
Thank you.
Mm-hmm. Yes. So that's yeah. So that's synthetic division. Again, it's just following just like a recipe, just following a formula or an algorithm, if you will. And just by practicing, it will become like muscle memory. All right. And the homework will provide you with some nice practice problems. But I think we can all agree that synthetic division is a lot cleaner, faster, and easier than polynomial long division. So it is very useful. It is very useful. All right, so we're coming close to the end here. Just have a few more things that I wanted to discuss. So do you guys remember earlier I kept emphasizing the fact when the remainder was 0, we could factorize our polynomial? That's what I want to just touch upon right now, okay? Okay, so kind of like, how can I word this? Yeah, so this is kind of just like a good situation. So suppose you're in the following situation. Suppose that when you do polynomial long division, or synthetic division, the remainder is 0. All right, so this is a very a nice situation, and the reason being, which I will formalize, but let me just explain it verbally. The reason is because when the remainder is 0, we can get a nice factorization of that polynomial that's in the numerator. All right. So let's talk through such an example that is in this good situation. All right. So an example is the following. So an example of something in this good situation, it is, right, so 4x to the third plus 10x to the second power minus 6x minus 20 divided by x plus 2. So first of all, I would like to check that the remainder is in fact 0. So I can do polynomial long division or synthetic division. So question to you guys, should I do polynomial long division or should I do synthetic division? Would someone like to tell me?
I would do synthetic division, and the term that you would use is -2.
Yes, exactly. So good. So just as Luke said, we are in the case when synthetic division is allowed, and the k value is -2, exactly. So just like Luke said, we're going to use synthetic division with that k value equaling -2. Excellent. Good. So let me just kind of roll through this. I just put the coefficients of that numerator in a row. So 4, 10, -6, -20. I put this box here, and outside of the box, I put my k, which is -2. That's the setup. Good, so I'm just gonna go through this slightly quicker. So you bring down the 4. 4 times -2 is -8. Put that right there. Now do 10 plus -8. Add up the column. That will be 2. Now do 2 times -2, which is -4. Add up the column. -6 plus -4 is -10. Do -10 times -2, you get +20. Add up the column, you get 0. Excellent. So look at what happened here. The remainder is 0. Remainder is 0. So that's very cool. And that's a good situation that we want to be in. So thus, we have figured out that 4x cubed plus 10x squared minus 6x minus 20 divided by x plus 2, this is equal to our quotient. So remember what the other numbers in this bottom row are. They're the coefficients of the quotient. So it will be 4x squared plus 2x minus 10. So that's how I get this guy on the right-hand side. 4x squared plus 2x minus 10. All right, so that's what we have determined, and there is a plus 0 because the remainder is 0, but I'm not going to write plus 0. Excellent. Now I can divide both sides by x plus 2, and that will give me the following. 4x cubed plus 10x squared minus 6x minus 20. That will equal x plus 2 multiplied by 4x squared plus 2x minus 10. So I hope everyone sees that we were able to factor this polynomial in the numerator as such. We were able to factor it as this. And that's why a remainder of 0 is very nice. It allows us to factorize like higher degree equations that we don't have techniques to do so. Okay, because if you were given this third degree polynomial, we don't have anything in our toolbox to factorize that. But now we have something. We have this polynomial division. Okay, so let me just kind of write what I just said. So first of all, we see that x plus 2 is actually a factor. X plus 2 is a factor of that numerator. It's a factor of 4x cubed plus 10x squared minus 6x minus 20. All right, it's a factor by definition because it's equal to x plus 2 multiplied by something else. So it is by definition a factor of this left-hand side. And we factored 4x cubed, I'm getting sick of writing this polynomial, 4x cubed plus 10x squared minus 6x minus 20. We factored this guy in the process, all right, in the process. So it's a pleasant consequence that we were able to factor this polynomial in the process. Okay, so that's what I'm getting at here, is that a remainder of 0 is a very nice thing because we can get a factorization of that numerator. Okay, and why do we like factorizations? Well, we can find the zeros very easily. We can use that zero product property. Okay. Okay, wait. So first off, hold on. Hold on that thought. Let me just kind of just wrap up this discussion. So the conclusion is, sorry, let me just backtrack a little bit. So the conclusion is that if in general, if p of x over x minus k has remainder 0, after performing synthetic division, then this denominator, x minus k, is a factor of the numerator p of x. And p of x will equal x minus k multiplied by q of x for where this q of x is the quotient. Okay? So if you do a synthetic division or a polynomial long division, you get remainder 0. You know that this thing that you divided by, x minus k, is a factor of the numerator. You can factorize it as x minus k times q. And how do you get q? Well, you get q of x just by doing the long division. That's how you get q. I write q for it because it's the quotient after performing the long division. All right, so that's kind of what we have, that's what we observe here in the process. All right, so let's go back to our concrete example and we're going to finish class. So returning to our previous example. Okay, so where were we at in that example? Well, I think we're up to the point where we factored, where we were able to factor. So I'm going to write this polynomial yet again. 4x cubed plus 10x squared minus 6x minus 20. So remember, the synthetic division allowed us to factor this guy as x plus 2, right? Was it x plus 2? Let me just... Yes, it was x plus 2 multiplied by 4x squared plus 2x minus 10. X plus 2 multiplied by 4x squared plus 2x minus 10. Okay, now we can use the zero product property. So now we can find the zeros of this third degree polynomial very easily. Now we can use the zero product property to find the zeros. So I didn't formally define what the zeros were. All the zeros of a polynomial are the numbers that when you plug into it, you get 0. So it's just like setting it equal to 0 and solving, and solving for x. Okay. So remember what the zero product property told us. It means that x plus 2 is equal to 0 or that guy is equal to 0. So we get this. X plus 2 is equal to 0 or that quadratic 4x squared plus 2x minus 10 is equal to 0. So now we're really getting into the use of polynomial long division. It allows us to find the zeros of these higher degree polynomials that we don't have formulas for. Okay, so we have to solve both of these. First of all, this one on the left is very simple. The answer to this is just x is equal to -2. Okay, so that's 1 0 of this cubic equation, this polynomial of degree 3. And how do we solve this guy? Well, actually, you can just use the quadratic formula. And we can use the quadratic formula to solve 4x squared plus 2x minus 10 is 0. Okay, so I hope we're not kind of losing sight of the big picture here. We're just finding the zeros of this polynomial 4x cubed plus 10x squared minus 6x minus 20 after we have factored it. Okay. All right. And now this is something we've done a few weeks ago. So we use a quadratic formula. I'm just going to write it pretty quickly, but you should verify this later. So x is equal to -2 plus or minus the square root. So what goes in the square root is b squared, so 2 squared, which is 4, minus 4 times a, which is 4 in this case, times the constant term c, and you divide that by 2 times 4, which is 8. All right, so just check this sometime later, okay? And now we can just simplify this. So this is -2 plus or minus. You'll notice now that the square root, the radicand, is just 164. All right, so just check that. Whoops, I wrote 168. It's 164 divided by 8. And so again, check. And this is, you can simplify the square root. This is -2 plus or minus 2 root 41 over 8. So this square root of 164 can be simplified as 2 times the square root of 41. Good. Factor a 2 out from the numerator and cancel with and simplify with this thing with the 8 in the bottom. You will get -1 plus or minus the square root of 41 over 4. Okay, so those are our roots. So in total, our zeros are the following. So remember, the zeros they came from these two solutions up here. So we already figured out very easily that one of the zeros was x equals -2. So x equals -2. And now we have 2 further zeros, one with the plus sign and one with the minus sign, with this plus minus. Another one will be -1 plus the square root of 41 over 4. And the last zero will be the same thing, but with the minus sign. So you take the minus sign. -1 minus the square root of 41 over 4. All right. So we were able to find the zeros of that cubic or polynomial of degree 3. All right, and this will be examined more next class. So this was kind of just like a preview of what's to come. This will be more, sorry, this will be examined more next class. All right. So, all right, so I hope that wasn't too painful. Yeah, so that's all I have for tonight. Homework 5 is due by midnight, and I believe that's it. So obviously stick around if you have any questions, and thank you so much, guys.